The topic which we are going to discuss is stack data structure. Upon completion, you will be able to explain the design, use and operation of a stack, implement a stack using a linked list structure, and understand the operation of the stack ADT. The main topic of stack which we are going to discuss over here are basic stack operation, stack linked list implementation, and application of stack. What is a stack? Stack is a data structure that stores data in such a way that the last piece of data stored is the first one retrieved, which is also called last in first out. Only access to the stack is the top of the element. For example, consider stack of coins, stack of books, whatever it is, the last piece of data stored is the first one retrieved. Another one example, you can consider the trays in a cafeteria. To get the bottom tray out, you must first remove all the elements above. The next we are going to discuss about the basic stack operation. The three basic stack operations are push, pop and top. Push is nothing but the process of inserting a new element at the top of the stack. Pop is nothing but the process of removing the next item from the top of the stack. This is the diagram of push stack operation. So the data which is going to be pushed onto the stack. So before inserting a value, the top of the stack, the top pointer must be incremented by 1. Then the value is inserted at the top of the place. Pop stack operation. So for deleting the data item, what it happens is the value will be deleted. The next step is the top will be decremented by 1. Top operation is used to point the first element on the stack. So this is the example, stack example. So here the first value green is inserted onto the stack. The top of the stack is initially null. So if we are going to insert a value, the top pointer must be incremented by 1. Then the value is inserted onto the stack. So next value is blue. So before inserting the value blue, the top pointer is incremented by 1 and the value is inserted onto the stack. If we are going to delete the element, for example here the blue is going to be deleted. So for deleting it, the value is removed from the stack, then the top is decremented by 1. Like this only various kinds of values are inserted and deleted from the stack. Next we are going to discuss about stack linked list implementation. So here we are going to present a linked list design for a stack. After developing the data structure, we are going to write some pseudocode algorithm for the stack ADT. We will discuss about it. This is the conceptual and physical stack implementation. As we know that linked list means which is used to connect together. The list will be connected together with the help of address. In each list, two fields will be there. One is data field and next one is next field. Data field which is used to store the value, and the next field which is used to store the address of the next value. And the most important thing is header node, which is used to store the address of the first node, because without the header node, that is dummy node or sentinel node, which is known as header node, is otherwise it is known as sentinel node or dummy node. Without header node, the entire list will be lost. So header node is the most important thing, in which it contains two fields. First thing is count field and second thing is top field. Count field is which is used to keep the value of how many nodes inserted onto the particular list. Top field which is used to save the address of the first element. So this is the stack data structure, stack head structure. This is the stack head structure which contains two fields, count and top, and stack node structure which contains data and link, data field and the link field. So stack operation we are going to consider in this example. So initially there is no stack at all. So if we need to insert a value, if we need to do something onto this stack, first we need to allocate the memory space. Then and then only we can do all the operations of the stack. So before there is no stack. So after allocating the memory space, empty stack will be created in which the header node is there. Header node consists of two fields, count and top. So initially the count field value is 0 and the top value is null. So after inserting a value green onto the stack, automatically the count will be incremented by 1 and the top value will be pointed to the new value, that is the new node, in which the data value is green and the next value is null. The top value of the header node contains the address of the value D, green. Address of the value green. Next we are going to insert the value blue. So if we are going to insert the value blue, again the top should be incremented by 1, which is the count should be incremented by another one, which is now 2. Next, I'm going to give the address of the value blue to the top. So automatically the link will be created. This is how the insertion operation is done onto the stack. Next, to delete. For deleting, the value must be removed from the link, then the top must be decremented. How we are going to remove the value? By replacing the address. That is how we are going to do the pop operation. And finally, destroy. Destroy means why we are doing this destroy? Because unnecessarily we should not allocate any memory. So after completing our operation, we need to destroy our memory space which is allocated for the stack. For this purpose only destroy stack is used. Now we are going to discuss about the algorithms of each process. The first thing is create stack. So as I said, initially there won't be any memory space. So in order to do any operations, we need to allocate the memory. So we need to allocate the memory for stack head, first step. Second, as we know that in stack head there are two fields, count field and the top field. Set the count field to 0 and set the top to null. That's it. Now the stack is created. First operation of push as first operation of stack is push. Here you need to allocate the new node. Here also we are having two fields, data field and the next field. So data field in which we are going to store the value and in the next field we are going to store the address of the next value. So first step, allocate the new node. Second step, store data in new node. Make current top node the second node. Fourth step, make new node the top, and finally increment the stack count. Next, pop. The most important thing before doing the push operation and pop operation, two important things are there: stack overflow and stack underflow. If the stack is full, then the insertion is not possible, and if the stack is empty, then the deletion is not possible, because if we have any space, then and then only we can able to insert a value. So stack overflow comes when the stack is full, and underflow comes when the stack is empty. So we need to check before deleting, before going for the process of pop operation, we need to check whether the stack is empty or not. If it is empty, set success to false. Else, set data out to data in top node. Second thing, make second node the top node. And third thing, decrement the stack count. And finally, set success to true. This is the algorithm for pop. And for top, again, there must be some value in the stack. Otherwise, top value will be null only. So we need to check if stack is empty or not. If it is empty, set success to false. Else set data out to data in top node, set success to true. So we need to set empty for empty stack and for full stack. So if stack count is 0, it is empty. So return true. Else return false. If it is full stack, that is memory is not available, there is no space at all, then return true, else return false. This is for counting the values, the field of head node. So we need the number of elements currently in this stack. We need to return the number of elements currently in this stack. So for this, stack count algorithm is used. And finally, destroy stack. So destroy stack, this algorithm releases all the nodes back to the dynamic memory. So if the stack is not empty, then delete top node. If it is empty, okay. Otherwise delete the top node and finally delete the stack head. Thank you.